Now, more exercises on Theorem 4 and its corollary. Let's take this exercise. Want to find the limit of x plus 2 to the power of 6 minus 64 over x squared plus 16x as x tends to 0. Look at the numerator. We have two terms. Keep this as the first term, and it has the x plus 2 and it has the power of 6. And the second term is 64. We can just change it into 2 to the power of 6, because 2 to the power of 6 is 64. What about the denominator? For the denominator, we have two terms with x, so we can just factorize it by taking out x as a common factor. Let's see. So, want to find the limit as x tends to 0 of, up we have, keep it as it is, x plus 2 to the power of 6 minus 64. Just down we have, take out x as a common factor of x squared divided by x to be x, and plus 16x divided by x to be 16, equal to limit as x tends to 0 of, this is the first part, take this as the first part, so x plus 2 to the power of 6 minus 2 to the power of 6 over x times limit as x tends to 0 of, write this as a fraction where we have 1 up and down, it's x plus 16 as x tends to 0. The first part we will change it to solve it by the corollary or by the theorem 4, and this part we gonna solve it by direct substitution. So this is equal to, first term here we have x plus 2, so we need to change this into x plus 2. If we add 2, we can simply subtract 2. The same thing for this part. We can just add 2 to match this and add 2 to both sides. So this is the first term of the denominator. Let's rewrite. So limit as x plus 2 tends to, now 0 plus 2 to be 2. And we have up, it's x plus 2 to the power 6 minus 2 to the power 6, and down it's x plus 2 minus. For this part, we can just evaluate it by the theorem. So we have n times a to the power n minus 1, or this is equal to n is 6, so 6 times a is 2 times 2 to the power 6 minus 1, or n minus 1, to be 5 times. This part we will do it by direct substitution and put x equals 0 in the denominator here. So 1 over 0 plus 16 to be 1 over 16, so times 1 over 16. So this is finally equal to, 16 means 2 to the power of 4. We can just simplify it with this, so 6 times 2 to be 12. Limit as x tends to 1 of 5th root of x to the power 3 minus 1 over 7th root of x squared minus 1. So limit as x tends to 1 of, this is the 5th root of x cubed minus 1 over 7th root of x squared minus 1. First, 5th root of x cubed means first x to the power 3, and 5th root, the index means put 5 down. Just put the index down in the exponent. So this is equal to x to the power 3 over 5. What about 7th root of x squared? This is equal to x squared, and down we have 7. Put the index down. So this is equal to x to the power 2 over 7. Limit as x tends to 1 of, this is very simple, x to the power 3 over 5 minus 1. Now 1 will take the power of 3 over 5, and down it's x to the power 2 over 7, 2 over 7, x to the power 2 over 7 minus 1 to the power, put 2 over 7 as a power for 1. Now we can just solve this by the corollary. So this is equal to n over m times a to the power n minus m. So this is equal to the power of the numerator 3 over 5 over the power over the denominator, which is 2 over 7, times a, which is 1 to the power 3 over 5 minus m, which is 2 over 7. So this is equal to the denominator of the numerator, just move it down, and the denominator of the denominator, just move it up. Keep the 3 as it is, and times 7, move the 7 up, and then keep the 2 down as it is, and move the 5 down to be 3 times 7 over 2 times 5. This is equal to 21 over 10, which is 2.1. Now take another one. Limit as x tends to 1 of 4th root of 5x minus 4 minus 1 over cubic root of 5x plus 3 minus 2. So the first term, we'll keep it as it is, but the fourth power means the fourth root means power 1 over 4. And for the denominator, keep the first term as it is, and the cubic root means power of 1 over 3. And let's see. It's equal to limit as x tends to 1 of, so 5x minus 4 to the power of, first root means power of 1 over 4 minus 1. 1 can be raised to the power over 4. And here we have, down we have 5x plus 3 to the power of 1 over 3 and minus 2. But here we have a problem. The first term of the numerator is not the same as the first term of the denominator. And we cannot make any change. We cannot change it. The first term cannot be changed because of the power. So the only way is to separate the numerator and denominator. So limit as x tends to 1 of, let's separate the numerator and denominator, and we have 5x plus 3 to the power 1/3 minus 2. I just separated the two parts of the fraction, the numerator and denominator. Can we multiply up and down by the same expression? So look at this. The first term here is, the first term of the numerator is 5x minus 4. So if we multiply down by 5x minus 4, and the second term is minus 1 or negative 1, so minus 1. So if you multiply up and down by this expression, this may solve the problem. So 5x minus 4, assume this is the first term, and minus 1. Minus 4 minus 1 to be minus 5, so it's 5x minus 5. So if you multiply up and down, the fraction will remain the same. So for the first term, we have limit as x tends to 1, 5x minus 4 to the power of 1 over 4 minus 1 to the power 1 over 4 over 5x minus 4 minus 1. This is the first part, and now it matches the theorem, and we can use the theorem directly. For the second part, this is, so just multiply by limit as x tends to 1 of, down it's 5x plus 3 to the power 1/3 and minus 2. For the numerator, we need to change this, or to rewrite this as 5x plus 3. So we need to add to be 5x plus 3. And if we add 3, we can just subtract 3 to cancel this change. So 5x plus 3 and minus 5 and minus 3 to be minus 8. Minus 8, so it's 5x plus 3 and minus 8. What about the 2? And here we have x tends to 1, so we need to make a certain change here to match this. And also here we need to make a certain change to match this. So we have 5x minus 4, so multiply both sides times 5. And if we need to subtract 4, so subtract 4 from both sides. So this is equal to limit as 5x minus 4 tends to 1 times 5 to be 5 minus 4 to be, so 5 minus 4 to be 1 of this 5x minus 4 to the power 1 over 4 minus 1 to the power 1 over 4, and down we have 5x minus 4 and minus 1 times. This is limit. Also here we need to make a change for this, so we want this to match this, so we want to change this x into 5x plus 3, so times 5 here both sides, in plus 3 both sides, to be 5x plus 3 tends to 5 times 1 to be 5 and 3 to be 8, and here we have 5x plus 3 and the power is nothing, so 1, and minus 8, keep it as it is because a is supposed to be 8, and here we need to make a change. Here we can just write 2 as a to the power 1/3, because a to the power 1/3 is 2, and down we have 5x plus 3 to the power 1/3 and minus a to the power 1/3, n or 1 over 4 times a, which is 1 to the power n minus 1 or 1 over 4 minus 1 times. The second part we have an exponent down, so we're going to use the corollary. So take the power of the numerator, which is 1, over the power of the denominator, which is 1/3, times a, which is 8, to the power of n minus m, or 1 minus 1/3 to b. So this is equal to power of the numerator 1 over power of the denominator, which is 1/3, times a, which is 8, to the power n minus m, or 1 minus 1/3 to be 2/3. Now this is equal to 1 to the power whatever. We don't need to waste time in simplifying this, because 1 raised to any power is 1, so this is 1 over 4 times 1 to be 1 over 4 times. If we have, whenever you have a denominator in the denominator, just move it up, so move the 3 up, times a to the power 1 minus 1/3 to be 2/3, so times a to the power 2/3. a to the power 2/3 means the 3 in the denominator of the power means cubic root of 8 squared. So this is equal to 1 over 4 times 3 times. Cubic root of 8 is 2 and 2 squared is 4. So 3 times 4. Now cancel the 4 and this is equal to 3.